Welcome to Maths with EJD. In this video, I'm talking about divergence of certain series, you know, um, and the concept surrounding this, the concept surrounding this is that we need to recognize specific series with known behaviors. So there are some series that have that specific behavior of divergence with known behaviors. Okay. So for instance, we have what we call the P series. We have P series. And the thing about P series is this. They are generally of the form summation from n equals 1 to infinity of 1 over summation from n equals 1 to infinity for 1 over n raised power p. Say 1 over n squared, 1 over n cubed, and all that. And usually this converges. This converges if p is greater than 1 and diverges diverges if p is less than or equal to 1. So if we have 1 over n, it's going to diverge. All right. And then if p is greater than 1, right, it converges and diverges if p is less than or equal to 1. That is what happens for p series. Then the second thing is that we have this other one called the geometric series. We've been dealing with that all along. We have the geometric series. So, and the key thing with geometric series is that given summation from n equals 0, mind you, n equals 0, not n equals 1, n equals 0 to infinity of ar raised power n, which is the classic geometric series. So this actually converges. This converges if the absolute value of r is less than 1. And what that simply implies is that if minus 1 is less than r and r is less than 1, that is what that expression means. That r lies between minus 1 and 1. Then the series will converge. Then, if not, it diverges. So diverges otherwise. Okay. So it means that if the absolute value of r is greater than or equal to 1, it will diverge. So starting from r equals 1, we are going to have divergence. Okay. So that is the idea about geometric series. So can we then take some examples to drive home the point? Um, let's start with example 1. Example 1. So we want to test the summation from n equals 1 to infinity for 1 over n raised to power half. Okay. I mean, we already know the rule for P series. This is the obviously P series. And we know it converges if P is greater than 1 and diverges if P is less than or equal to 1. So in this case, uh, so here, here we see that P is equal to half and P is less than 1. So, so the series summation from n equals 1 to infinity of 1 over n raised per half actually diverges. So with this, we don't even have to waste time at all. Don't have to waste time. So the next thing is, let's see what example 2 looks like. So example 2. So here, let's test summation from n equals 0 to infinity. Summation from n equals 0 to infinity of 1 over 2 raised to power n. Okay, so here we have, so this is like the geometric series. So this is the geometric series with r raised to power half. I mean, how do we mean about that? We have summation from n equals 0 to infinity, 1 over 2 raised to power n. That's the same thing as summation from n equals 0 to infinity of 2 raised to power minus n. Okay? 2 raised to power minus n. So in this case now, we have, when n is 0, we have 2 raised to power minus 0 plus 2 raised to power minus 1 plus 2 raised to power minus 2 plus 2 raised to power minus 3, and so on and so forth. So in that case now we have 2 raised to power, 2 raised to power 0 is just 1, and this is 1 over 2 plus 1 over 2 raised to power 2 plus 1 over 2 raised to power 3, and so on and so forth. So you can see that it is actually true that this is geometric series with r raised to power half. This is 1, because this is 1 now. 1 times half is half. Half times half is 1 over 4. I guess I want to give it some space, some breathing space for that matter. So, this is like 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 plus all this. So if you keep multiplying by half, so you see that here we have, it's actually a geometric series with r equals half. And for geometric series, they never converge. So r raised to half simply implies, I mean, r equals half. I mean, r equals, oh, did I say never converge? Sorry, don't mind me. For geometric series, right, we have conditions. I'm so sorry. We have conditions that geometric series converges if absolute value of r is less than 1. So for r equals half here simply implies that it implies that, you know, it implies that the absolute value of r is less than 1, okay? Because the implication of this is that minus 1 is less than r is less than 1. That means r lies between minus 1 and 2. And of course, it is correct that minus 1 is less than half and half is less than 1. So as a result of that, the condition, as we as stated already, tells us that if absolute value of r is less than 1, then the series converges, okay? So we can conclude and say that it actually converges based on the fact that r is half. So this geometric series, which is summation from n equals 0 to infinity of 1 over 2 n, actually converges since r is equal to half, which r is equal to half, which implies that the absolute value of r is actually less than 1. So the series converges. All right. So let's see if we can get practice questions on this. Let's see if we can have more examples so we can have some practice questions in this line. Okay. All right. So check this out and tell us why they diverge or converge. So we have practice questions. So generally P series and geometric series. So practice questions. Okay. So test 1, test 1, summation from n equals 1 to infinity, n squared over 2 raised to power n. Test that whether it converges or it diverges. Then we also have this summation from n equals 1 to infinity of 3 raised to power n divided by n factorial. Check that out. Then I think one way to do it is you can get the first few terms to see what it looks like. I mean, we had to do that for the last example I took, right? I mean, just looking at this, if you don't break it down like this, you may like what I did here, you may not really see the fact that it is a geometric series with r equals half. So you can also try this out. Summation from n equals 1 to infinity of 2n factorial all over n factorial raised to power 2. Okay, that's some thick thing to handle. Then we have the fourth one, which we want to try. So you have summation from n equals 1 to infinity of n factorial over n raised to power n. This is some very huge stuff. So we have a fifth one even, where we have you want to test the series summation from n equals 1 to infinity of 5 raised to power n all over n raised to power n. Okay. Yeah. So, I mean, if you can try your hands on this to be really good, to make you really solid with things like this. So we have certain series that diverge. All right. So the playlist on sequences and series still continues, and just watch out for the next set of videos. So if you have not subscribed to this channel, you don't want to miss out on anything, you want to do that right away. All right, you want to do that right away, and then hit the notification bell so you can always get alerted each time a new video is released. Then of course, comment, let me know if there's something, if there's a topic you'd like me to teach or a problem you'd like me to solve. Then while at that, you also want to like and share so that more people can see, more people can have access to this great uh, channel and learn all the all the things that there are to learn. All right. So till I come your way again, keep doing great. Bye.